So yeah, thank you guys for coming on. Arjun and Rahul. We all go to the same university, we go to the same college. That's how we know each other, and we're all interested.
Highly
We
qualified.
all, pardon?
Highly qualified.
Yeah,
highly
we're
qualified.
all highly qualified in our own right to talk about COVID-19. Rahul does medicine and Arjun does biochemistry. I do PPE, which makes me qualified, you know. But anyways, so yeah, Arjun, I just wanted to ask you, because you're a biochemist, right? What exactly is the coronavirus, and why is it that people say we've had, you know, close versions of it in the past?
So viruses in general aren't living things. They're not considered part of the living world because they only are alive effectively inside of a host. So
Yeah.
they enter a cell, take over the host cell, and then basically cause the cell to lyse and release a bunch of further viral particles.
Yeah.
The coronavirus is, well, it's called a coronavirus because it is a coronavirus, but that's not its actual name. The coronavirus itself is what's called SARS-CoV-19, which is a type of coronavirus that's related to the SARS disease that came out earlier.
And that's a severe acute respiratory syndrome, right?
Syndrome.
Yeah.
Yeah. And both of them are thought to have come from bats.
Mm-hmm.
And both of them they come from bats, but they don't go directly from bats to humans. They're thought to go through like an intermediate animal, like SARS went through the civet cat.
Mm-hmm.
And COVID-19 has thought to be have gone through the pangolin, if anything.
And so the difference between SARS and the original SARS, the 2003 SARS, and COVID-19 is how infectious COVID-19 is. Why is it so different?
There's still a lot of like different thoughts as to why it's so infective, and as to has it mutated and given itself some leg up over all the previous versions. But one thing that they're noticing in research is that it tends to infect more people faster earlier on in the disease. So when a person gets infected, they start spreading the illness to other people before they realize they're sick. And so that actually causes them to spread it to a far larger number of people than if they get sick and they would just stay at home and infect less people, or go to a hospital and then infect less people. So that's one of the main differences. Similar thing with another closely related coronavirus, which is MERS, which is the Middle East Respiratory Syndrome. Both SARS and MERS were far more deadly than coronavirus. MERS killed up to like some 35% of like every person infected, whereas coronavirus is thought to infect anywhere between like 0.5% to 2%, 3% of people.
Kill, yeah. So yeah, anyways, Rahul, I was just wondering, perhaps you could give us in layman terms a little bit about the science behind the virus. What actually is it?
So as Arjun said, it's not really considered a living thing. It basically, so the virus particle outside of your host cells is just a piece of RNA, which is like, it's similar to DNA, it's like genetic material. And that's surrounded by a protein. And that protein is surrounded by a lipid like membrane that it takes from its hosts. And on the surface of that like lipid, around the outside of it, it has receptors. It's a glycoprotein that binds to specific receptors on some of your cells. And you find these receptors like in the lungs, in the kidneys, in the spleen, in the gut. And that sort of determines which cells it can like infect.
Why is it so detrimental to our lungs specifically? What is the nature? Why is it? Yeah.
So it's a respiratory disease. So you get it from like touching your face, and it enters into your like respiratory system, or like from like water droplets that have the virus in. So it gets into your lungs first. That's like the first part of your body it reaches. And there are specific cells in your lungs, alveolar cells, that have the receptor that the virus binds to. So it's just very good at getting into your lungs, essentially. And once it's inside, it can kill your lung cells. It gets the immune system to come, and that damages your lungs even more.
And I
But yeah,
suppose,
when the disease gets worse, it can spread to other parts of your body as well. So
yeah.
But it also
And I
it has a
suppose,
progression.
yeah,
So it hits your upper respiratory system first, and then it goes down. And once it reaches your lungs, then it actually gets deadly, and it tends to cause pneumonia and so on and so forth, which is actually dangerous.
and that's just a buildup of water in your lungs.
So also,
yes,
which
like
basically means you
inflammation.
can't pull oxygen from the air anymore.
Yeah.
Yeah, and that's why you see those videos in the hospitals of people being turned upside down to release the pressure in their lungs, right? But I mean,
I haven't
anyway,
seen them.
have you not seen that? That's very common. So
Oh, really?
I mean, I'm sure you understand why, but if you turn someone
Yeah,
on their stomach,
Mm.
the pressure is not on the back of their lungs more so than the front. They have more space to breathe. Anyways, now I think what a lot of people also been wondering about are the symptoms, because there's so many and they're so general. We know that things like coughs, sore throats, fevers, but then we also see people reporting things like a loss of smell, a loss of taste. I was wondering, Rahul, why is it that the symptoms are so wide, and why is it they're not true to everyone?
So they haven't had enough time to research the pathogenesis, like the disease, that much. But there are quite a few theories as to like why it affects people more severely than others. So people have said like old age is a risk factor. It's mostly because like as you age, your immune system becomes like less capable of dealing with new pathogens that it hasn't seen before, because you have less like white blood cell, like your bone marrow and your thymus become less good at making white blood cells, basically.
And you
But
were
apart from
mentioning
old
something.
age,
You're mentioning genes, which is really interesting. If you could just talk about that.
So this hasn't been researched like at all with regard to like COVID-19, but with a lot of other infectious diseases like tuberculosis, HIV, there's like a big genetic risk factor from a part of your genome called like the HLA genes. There are 6 of them, and you get one copy from your mum, one copy from your dad, and it's like codominantly expressed, so both of those genes are important. And basically they determine your sort of immunological identity. It's sort of unique to you, and it determines how susceptible you are to specific like pathogens. So there are some famous examples, like there's a specific allele that means that you're better at dealing with HIV, but you're like more likely to get specific autoimmune diseases. So yeah,
and so why is it that so is that specific to race or region in the world, or is it muddled up whereby you can't differentiate people's genes based on where they are or where they're from?
So I think it probably is reasonably related to race. You probably have HLA alleles that are better at dealing with like malaria in sub-Saharan Africa, that sort of thing. So you probably do get sort of trends within race, but these alleles are like extremely variant within populations. Like I think they're the most variant alleles in your entire genome. So there's probably some trends within races, but it's very, very variable.
Yeah. And so when it comes to how we're looking at the transmission of the disease, because as you both were saying, it's so infectious. One of the big touching points were masks. The WHO announced that masks are not necessary, only for people coming close to people with infections. But I think in hindsight, we've realized that masks are actually probably quite useful in stopping the spread of the infection.
That's
so
exactly what they were saying in China as well. All of the Chinese doctors and the experts were there have already said that masks were critical in slowing the spread of the disease, which has slowed considerably in China. And basically, masks early on in this entire epidemic weren't that useful, because the majority of people who were wearing masks weren't actually coming into contact with the disease anyway. So what they were actually doing was taking away from the total number of masks available to healthcare professionals.
Yeah.
But now that the disease is running rampant all over the world effectively, it's becoming more and more important that having a mask stops people from either both spreading it and contracting it. And the
so
type of mask is
yeah. So on the importance of the type of mask, there was this video of the Surgeon General of the United States taking a T-shirt and teaching people how to fold it to a mask. And I was wondering, how is it possible that a T-shirt, made in a factory out of thread, is going to have the ability to stop the particles, which I'm sure are much smaller than that.
Well, that's the thing. It's varying degrees of effectiveness. So what people are talking about a lot right now are the N95 masks,
Yeah.
which have caused so much of political drama as well in the US and Canada and so on and so forth.
Yeah.
But the thing about them is those are most definitely the most effective masks.
Mm-hmm.
Okay, the next level down are the regular old surgical masks that you see in hospitals or are available at a pharmacy and so on. And even with the T-shirt and stuff, they do work to some extent because it's still better than directly breathing in the air. You're still going to catch the large droplets. If someone sneezes in your environment, you're still going to catch the large droplets on the T-shirt. It might not give you a lot of protection, but it's still going to give you a fair deal of protection.
Yeah.
The only thing probably that isn't that effective are like dust masks and so on and so forth, which you see a lot of people wearing, and a lot of people are selling irresponsibly, claiming that it will help you.
I'm sure this is based in the desert where you are, not so much.
Well, I mean, it's actually fairly common. It's in Amazon and stuff like that. If you ever look, you see literally hundreds of sellers now for masks selling it at like vastly inflated prices.
So I think in Malaysia they've introduced price controls on masks, which is pretty necessary. But yeah, so
very necessary.
So we're all based in different countries. Obviously, Rahul's in the UK, Arjun's in UAE and Abu Dhabi. And I was just wondering what the lockdown experience has been like. So I know the UK were late to it, and Rahul, maybe you might want to explain how life's been.
Yeah. So at the start, they sort of they had a kind of weird like philosophy with dealing with it. They had the idea of like allowing it to pass through the population and people get herd immunity.
Yeah. Which they really believed in.
They did. They really believed in it, and they were quite late to initiate any sort of real measures like lockdown or closing shops, whatever. And there's some evidence that there was a mathematical model from Imperial that the government was made aware about. Yeah, they predicted that there could be like a 250,000 like death toll if they carried on with the herd immunity tactic.
Yeah.
And that sort of they sort of had a U-turn after that, and they slowly started implementing like the lockdown. They closed bars and restaurants, and then there was like a full lockdown. But yeah, apart from that, there've been a couple of like points in the press about the response. There was quite a lot of criticism with the government that the NHS staff aren't getting enough PPE, like personal protective equipment. Which is obviously it's like terrible for them because like they're very exposed to it, but like it also means it's going to spread quite a lot in hospitals to patients who are quite vulnerable. So
it's just crazy. I think I was reading the news on Thursday last week, and there was a memo sent out within the NHS saying that this weekend they're going to run out of PPEs.
Yeah, it's crazy.
Which is crazy. But I also think that the press in the UK are extremely quick to challenge the government. Every morning I see Piers
on
Morgan.
Everything.
Piers Morgan.
On everything.
Yeah.
And no matter what government it is.
Exactly. Which is good, but it must be frustrating for them.
They have a thing every day where the press get to talk directly to whoever's in charge. It's not Boris Johnson at the moment because he's still ill. No. It's mostly Dominic Raab, but yeah.
Yeah. So Arjun, what's life like in the UAE? I know you were the first to leave Oxford, and you were telling me about your plane ride back, and how So how about you start with that?
Well, basically, the plane ride back. Once we landed, normally you taxi to the terminal and you get off. but they just stopped the plane there. They didn't let people get off, and it was like maybe 15, 20 minutes. And then we heard the door opening, but we just weren't allowed to get out of our seats. And basically what happened was they eventually let us out through one side of the plane, like throughout the two aisles, they let us out through the far side of the plane. And as we went through first class, we see 3 people are just sitting there, and like a whole bunch of, I suppose, it's infectious disease agents or whatever. I don't know what the agency is here.
In hazmat suits and stuff.
Yeah, in the full hazmat suits and everything, and 3 of the passengers are just sat down in the seats, and there's like security around them and everything. So we were quite nervous about it, but eventually it was fine. There weren't any issues about it. In general, in the UAE, it's mostly a complete lockdown. There's a curfew. I'm sure it's enforced a lot more effectively than in the UK.
Yeah.
You can't exactly go out. Everyone who's out on the street, everyone without question or exception has a mask. If you have to go to buy groceries, or you have to go to if you have to go to a mall or something and buy groceries, you have to have a mask. For a time, they were even insisting that you wear gloves and masks if you had to enter the mall. You're not allowed to be outside after 8 p.m. unless you have, a reason to be there, which is like given to you by a license from the government. And then other than that, they've just shut down everything.
It's crazy to think that in different parts of the world, the response has been so different. When you look up
here,
the US,
they can afford to be cautious, and then you've got the US, and the US basically has this sort of like, it just gives you the impression of chaos.
Yeah, definitely.
Mean, objectively, Trump is speaking very irresponsibly. I don't think I'm being political in saying that. He's being very irresponsible in his words. And the state governments are just ignoring him to a large degree. Started triage for patients that are so badly hit that they have not enough ventilators, and they're just not giving ventilation to patients over some 79 or something, and they're just sending them into hospice care, or like sending them home. And then on the other hand, you have Sweden as well, which is basically doing what the UK thought it would do, and stay hard and fast on the
I think they're going to pay the price for it.
They are going to pay the price for it.
I was watching a report on the lead virologist in Sweden, who was the head of the Center for Virus and Disease Control, pleaded to the government to impose a lockdown, but no response, obviously. I think it's hard for a government to retract so late into their response.
Because it's already too late in that sense. I mean, the virus is already like effectively disseminated throughout the population, hasn't it?
Yeah.
So I mean, they are going to pay heavily.
I wanted to come back to the herd immunity thing that the UK were trying to do. From what I understand, herd immunity works with a vaccine very well if you can get a certain percentage of the population vaccinated and immune. But why do you think medical advice in the UK was to follow herd immunity instead of locking down? Because the government always say that they're following medical advice in anything they do.
Yeah, I don't think this would have been medical advice, to be honest. It seems because the problem with having a herd immunity tactic, especially in the UK, is that the NHS works like close-ish to full capacity normally. And so if you have a virus, they just let it go through the population. There's I think 20% of people need hospitalization with COVID-19. So if you suddenly have 20% of the population,
your Prime Minister had to go into hospital. That's how bad.
Yeah, exactly. Well, he's still ill. The health secretary got ill as well. So it was kind of ridiculous. I think they were looking out for the economy a little bit more than listening to medical advice. And then they realized that the economy would be fucked anyway. So they lost the economy and they lost the population, really. They lost for everything.
Yeah.
They massively lost it.
Because it works in principle, herd immunity as a concept, it very well, it works in principle, because if you get enough of the population infected and immune, the virus is just not going to spread.
Yeah.
But the problem is, in the meantime, while you're developing this herd immunity, so many people are going to be very ill, and you need to have the ability to deal with so many people being in, and you need to have the resources. And someone yesterday, I had a tutorial yesterday, and my professor told me that the way it works is comparing the UK and Germany. The NHS is working on almost to capacity all the time, exactly like Rahul said. So they have the number of spare beds that they have is almost nothing in like in a large scale. But Germany almost keeps its almost runs its entire healthcare system at double the actual required amount. So
50% capacity.
Yeah, 50% capacity effectively. So that's very expensive and it's not economical. But when something like this happens, it's a godsend.
Yeah. I was even watching a video of Germany helping out France, at the border. It was German paramedics and German hospitals dealing with French people who were sick, which is just crazy to think of. But I wanted to move on to testing, because I think that's like what everyone says is going to be the saving grace. If you can get 100,000, 200,000 tests a day in your country, that's going to be the reason why, you get out of this. And then if you look at South Korea, who've done massive amounts of testing, they've managed to flatten the curve and keep deaths and infections so low, everyone else is so surprised. So yeah, I mean, either one of you just wanted to talk maybe about the conventional tests that we have.
Well, I mean, there's testing is extremely effective, but also it is very expensive, especially in the developing world. Most people are just not going to be able to afford it. You're going to have the government to pay for it. That's the only way.
It seems like there's a massive battle to even get tests.
Yeah, in so many places, you just don't have enough resources. Like Oxford sent out an email to all of us. I don't know if Rahul got it as well, asking at least all of the biochem department got it, saying that if you have any sort of biochemical lab skills, come and help out. Help us run these tests. And it's that's how short they are of resources. But testing works effectively.
So Rahul, you probably know well what the benefits of antigen testing is, and then also antibody testing. So maybe you could give us an overview of the difference.
So antigen testing is a way of seeing if someone has the virus like in them at the moment. So it's used in hospitals. It's diagnostic. It's basically it's a test to check if the viral RNA is there, so the genetic information is actually inside a swab. But some of the problems with this test, the antigen test, is that it's not actually, it doesn't always give perfect results. There's quite a lot of like false positives, false negatives.
How does that work?
And so I'm not actually sure. I think it's quite difficult to get. So it's a PCR test. It has like a it's a test that like amplifies. So it makes lots and lots of copies only if the specific viral RNA is there. Okay. And it does that because you have primers that are very specific to just that piece of viral RNA that you're testing for.
And if it doesn't detect it.
So yeah, if it doesn't detect it because it just happened to not be in the swab that you took, then it will give you a false negative. But also, I think if you have similar-ish viruses, like there are quite a lot of coronaviruses that are in common circulation, like they cause colds and stuff. That's possibly a way to get a false positive. But yeah, antigen tests only show you when you actually have the virus like within you. So you can't check if someone's had the virus and they've recovered from it. You need an antibody test for that, which is sort of like the next stage that people are talking about.
Arjun, do you want to talk about antibody tests? Because I don't really understand.
Well, I mean, I'll let Rahul talk about the testing, the antibody testing itself. But I just wanted to talk about the PCR test that he just mentioned,
Yeah, go ahead.
because that's exactly the test that they were asking us to perform
Okay,
or
yeah.
help out in.
Yeah.
So basically what it actually is you have a very small amount of DNA. If you take a swab or you take a sample of blood or, like mucus or something from the upper respiratory tract, and you have a very small amount of DNA in it, and it's a jumble of your DNA as the host. It's jumble of the viral DNA, and it's a jumble of like all different other bacteria and microorganisms that are there. So then you need to take that small amount of DNA and make a bunch of copies, so you have enough to actually have a detectable amount in it.
Mm-hmm.
And that's what PCR does. It takes your really small sample of genetic material, in this case RNA, and it amplifies it, which makes millions of copies of it. And then you can test for the presence of that DNA. So that's basically what the test actually does. And a lot of the time, the reason it's so sort of, it's not reliable, they say. It's pretty reliable, but the thing is, it's just DNA as a whole is basically 4 bases, A, G, C, T, and RNA is A, G, U, C. And all of these come in a bunch of different combinations. And if you have the wrong primers or the wrong things that are just not specific enough, you're going to get a massive false positives.
Yeah.
And if you do it wrong and RNA denatures really fast and you saw your sample wrong, the entire thing is just going to turn out negative, even if you do have it.
So like a friend of mine in hospital in Malaysia for COVID-19, what they do is if you test negative twice in 24 hours, they release you. And
exactly.
I think for she was in hospital for 3 weeks, and there was so many times where she would test negative and then test positive again. And that just goes to show you that, tests aren't 100% accurate.
Yeah,
and
definitely.
that's another thing though. In South Korea, this bit of research coming out of South Korea, 91 people who did the thing about 24 hours to tests are being negative. They test positive later.
Mm-hmm.
Why is that? Nobody's too sure. A lot of the time, people were panicking about the fact that could you get reinfected by the virus and not actually gain an immunity to it.
Mm-hmm.
Whereas other people just think that it's much more likely that you do get immunity to it, but these people were released early and the virus was just dormant in their system rather than actually eliminated, and it has reactivated now. So that's the problem with this RNA testing, as we say.
I think
I'll leave
it's the wider problem of the whole COVID-19. We just know so little about it. How it works.
It just hit so hard so fast, right?
Yeah.
And we just don't have enough data.
And so about antibody testing, I assume it figures out if you're immune to the virus. But first of all, what is it? And second of all, can people who have never had the virus be immune to the virus?
Okay, so basically, when you've had the virus, one of the ways that your immune system deals with it it finds a bunch of B cells. These are these like immune cells that have sort of antibodies on their surface, and it finds the B cell that can bind onto the spike protein on the virus. So that's the protein that binds onto the receptor on your cells. It's and like if you find the right B cell, like a lock and key, so if you find the right B cell and let it make loads of antibodies, then you have all these proteins floating around in your blood and around all the inflamed tissues that can bind onto the spike protein, and now it can't bind onto your cells. So they say it sort of neutralizes the virus. So that's quite a good way of stopping your cells getting infected over and over again by the virus. So, and the idea is that around 10 to 14 days after the infection, you have a specific type of antibody floating around that's able to bind onto the spike protein. So if you have a lot of that in a Petri dish or whatever, then if someone has antibodies in their serum, it will bind to it and you'll be able to detect it. But it's quite difficult to see how useful it is at the moment because we don't know what level of antibody is sufficient to give you immunity. And it's not actually been confirmed that you can get immunity to the virus, even though it's likely that you will be able to, but it's not been confirmed.
And is making a vaccine as simple as taking out that antibody and putting it into a vaccine, or is it much more than that? I'm sure it is.
No. So the vaccines that they're looking at the moment are they're viruses that can infect human cells but don't cause disease, and they've like genetically engineered them so that they make some of the coronavirus proteins, and that means that when you give someone that virus, their cells will start making the protein, and your immune system can encounter those proteins without actually being infected with coronavirus. What you described is more sort of like using serum, like convalescent serum to treat it. So.
And Arjun, I know you know quite a bit about what's going on with the vaccine in Oxford, especially.
Well, vaccines are being developed all over the world. Oxford is basically one of the big centers in the UK that are trying to do it for the UK, and they say they're going to have a vaccine ready by September. They also say that it has an 80% chance of working, which doesn't sound very high.
They're
Is
overconfident.
Is 80% favorable in the medical world, or is it?
It's not really a question of medical world. It's the fact that in such a small, short space of time, where normally a project like this to develop a vaccine takes years and years.
Yeah.
Especially to do it from scratch.
Yeah.
I think they're overconfident.
They probably are to some degree, and they're trying to calm the public down.
Yeah.
But basically, the reality is that this coronavirus situation is going to exist in human everyday life until a vaccine that is reliable is found.
Yeah.
It's not going to go away.
No.
Because in the end, you're just constantly going to have at least some small amount of the population that carries the virus.
Yeah.
So it's happening in China now. They basically are easing lockdown, and cases are starting to reemerge.
Yeah.
Well, in Hong Kong as well, and all of these are very worrying signs. And the vaccine, or perhaps an effective treatment, is maybe the only hope that we have of reaching a completely normal life again.
And so treatment, I mean, there are so many different drugs being prescribed by people from, medical directors to the president of the United States. What do you guys think is the most promising? And why?
So, firstly, it's important to point out that there have literally been no good, reliable randomized controlled trials on any treatment. So you can't really say any of them work at the moment. I think at the moment chloroquine is looking like the most promising, but the study that they did with chloroquine wasn't particularly reliable. But it has a reasonable scientific basis for why it should work. But I reckon chloroquine is probably the most promising.
And how does it work? What does chloroquine do?
So it's usually used as like an anti-malarial. It's just it's a lipophilic base, which means it dissolves well in fats, and it's like an alkali. So it can cross through your cell membranes quite easily. And because it's a base, it accumulates inside acidic compartments within the cell. So it accumulates within endosomes within the cell, which are sort of vesicles inside the cell that the virus will be inside trying to get into the cell. And because it makes those acidic compartments more basic, it's now difficult for the virus to enter the cell.
And when you say basic, you mean alkali, right?
Yeah, alkaline, yeah.
Okay.
Yeah.
Okay.
So there's that, and there's also some evidence that it works it sort of sits in your cell membrane, and it lets zinc from your blood get inside cells, and zinc inhibits specific enzymes that the virus uses, so it can't replicate. But there hasn't been enough research on it for COVID-19 specifically.
Yeah, that's just what I was going to point out. A lot of this research is geared as to how it works on malaria and what it actually does there. And it's almost completely incomparable because they're basically different streams of life. As in, malaria is a eukaryote, sorry, and COVID-19 is a virus. So people are very unsure. This is how it could work, but there's almost there's very little evidence that this is actually how it's working, or if it's working at all.
Yeah.
The major studies that sort of have been brought up, especially by Trump and so on and so forth, they're really, if you actually look at it, the actual sample size was 20 people who actually had the coronavirus and received hydroxychloroquine.
Yeah.
Which is in the scale of medical studies, nothing. Okay, it's an insignificant amount. Normally, when a drug goes through studies, it literally goes through thousands of people, both people who are sick, both people who are healthy, just to look at side effects, not look at side effects. And a lot of the time when someone or a politician or a member of society says something like this, you're going to have price gouging of these chemicals from like the suppliers. And I read about cases where people are they're taking like industrial quantities of chloroquine, and someone took a vial of chloroquine that's normally used by goldfish breeders to
this was in the US.
Treat an entire pond, and he took it and he died. So basically, it's very irresponsible.
Because there's there's different forms of chloroquine as well. Not all of it.
And it's just such a massive dose.
Yeah. It's a dangerous drug. It's definitely very dangerous.
What about the more straightforward option of injecting people with the blood of people who've recovered?
Well, I mean, the blood, or you can isolate the antibodies and inject that. That is probably currently what I would think as the most scientific treatment, because that would help treat people to a large extent. And but again, that won't necessarily give people immunity, because like Rahul said about the B cells, your own B cells need to be trained effectively to recognize these new pathogens, these new viruses, and that's not what happens here. So you don't get immunity by injecting antibodies.
Yeah, it's a short-term fix.
It's a very short-term fix.
But I suppose
plus you're going to have to inject a lot.
I mean, at this point, any sort of fix is probably going to be well received.
I think
another major one would be the HIV drugs that people are testing. Like HIV protease inhibitors. Those basically, what the virus does is, like Rahul explained, it's like RNA inside of a coat, a protein and a lipid coat, and it's just the RNA part that's injected into the cell. And what that effectively does is it goes and it hijacks the cell's machinery to produce viral proteins. And basically, protease inhibitors stop that protein from becoming functional.
So it stops the protein that stops the protein
from being functional effectively. The protein is technically it's created, but it's not functional. It's not folded correctly. It's basically in a long line and so on and so forth, and it just cannot work. And that's where you basically halt the disease cycle. And that's basically what's being done with HIV, and that's why HIV now, your life expectancy is basically that of a healthy being. And that's another promising treatment. But again, there's little to no current evidence that it's going to be effective in the same way against COVID-19.
Yeah, because I mean, especially with HIV, they've had years to come up with something, robust. And I think naturally we should probably expect something similar for COVID-19. It's not gonna. I doubt we're gonna come up with a vaccine this year.
Well, maybe vaccine is another thing, but HIV and coronavirus work very differently. They as diseases are completely separate. They are technically viruses, but they are very different diseases, and it's hard for you to it's hard for us to, at this point, with very little knowledge of coronavirus biochemistry, to actually say that these are the points that they're going to be similar and these are the points they're going to diverge. And so when you can't have that, you are effectively not going to be able to draw analogies with other viruses. And that's the problem currently. So you're not going to be able to say that if something worked here, it's going to work here as well. So that's the major issue.
So yeah, I mean, think we've talked about a lot of different things. I think to finish off, let's probably talk about the US, because I think the US is very interesting, especially with the whole political situation and Trump. What what why do you think some countries are so unprepared as compared to other countries?
I think, well, especially countries in like the Far East have had like more experience with this sort of like endemic, like sudden infectious diseases coming up, like with SARS and with MERS and bird flu. So it's given them a sort of like trial run for something bigger, but you haven't really got that happening in America or in the UK, in Europe.
No.
So there's less of a sort of protocol in place for what should happen.
And plus, the US is just uniquely placed to not have a good time with this thing. I mean, with the price of healthcare, so many people uninsured. That's another thing. In Asian countries, like for example in India, healthcare is several orders of magnitude cheaper than it is in the US.
Yeah.
And normal people can afford to go to the doctor more in India than they can in the US a lot of the times if they're uninsured.
Yeah.
And that's one thing. The other thing is you have got a ton of misinformation floating around. Have you been, I'm assuming everyone's seen the anti-lockdown protests that have been going on.
Oh yeah.
Where people think that the coronavirus is a conspiracy, that it's not real.
I heard the classic COVID-19, it's the 19th version of the coronavirus. We've had it 18 other times. We don't have to worry about it.
Yeah, I don't know if that one was like legit, if someone was actually dumb enough to say that, but yeah. And
well,
then
no, I mean,
lock Bill Gates up, it's Biden's fault, all that type of thing.
There was a Trump White House official who said that.
Seriously?
Really?
Yeah, if I can find it, I'll send it to you guys after this. But yeah, I mean, yeah, it's weird.
Like
I think it also I think a lot of people have realized that, you know, over the years, especially in the UK, austerity has really decimated the healthcare system.
The NHS just doesn't have enough capacity to deal with it, I think.
No. And you know, if you look at the US as well, where for many, I think people will start realizing that things like, you know, the Affordable Care Act are unnecessary things, you know, for us to have as a society. We're lucky that in Malaysia we have a relatively functional, you know, public healthcare system, and I think a lot of the countries that do well with this virus have that, you know, like South Korea and Germany.
Yeah, they're not testing like in India.
Which is completely different.
Yeah, India just declared the state of Goa completely coronavirus free.
Really? Well, they haven't tested.
They've only tested 800 people in the entire state, and it's got like a population of 1.8 million or something like that, which I find fairly bizarre.
Yeah, well, I mean, I think the WHO issued a letter saying that for you to be relatively safe, you need to test 100 people for every one positive person.
Yeah. And that's coming back to testing. That's exactly what testing does. You start isolating parts of the population that do have the disease. And what you do is you reduce basically the turnover rate of infection. So the infection rate drops in China, for example, it drops from 2 point something to like 1 point or less than 1. Sorry. So basically that means that each person who has the disease used to infect at least 2 or 3 uninfected people and give them the disease. And now that's dropped to each person gives less than 1 person the disease. And so the virus actually shrinks within the population.
Yeah. So like what South Korea did really well, and I think Malaysia also tried to do, is contact tracing. So being able to you know, isolate who people have come in contact with, and then from there branch out. And in the UK, where for the initial stage, they let everyone go around doing their daily business. It's very difficult to implement contact tracing after that.
Yeah. It's like the complete opposite strategy, really.
But yeah, I mean, thank you guys for coming on.
Yeah, no worries.
This is we're gonna have a lot more podcasts, and I hope to have you guys on for further ones, maybe in 5 years' time when we're still grappling with the coronavirus.
What, 50-year rustication?
Yeah.
Yeah, exactly.
Yeah, okay.
All right. See you.
See you guys.
See you guys.